Chapter 6, Part 6 of an Inquiry into the Human Mind on the Principles of Common Sense. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by K. Hand. An Inquiry into the Human Mind on the Principles of Common Sense by Thomas Reed. Chapter 6, Part 6. Section 21. Of the process of nature in perception. Although there is no reasoning in perception, yet there are certain means and instruments which, by the appointment of nature, must intervene between the object and our perception of it, and by these our perceptions are limited and regulated. First, if the object is not in contact with the organ of sense, there must be some medium which passes between them. Thus in vision, the rays of light; in hearing, the vibrations of elastic air; in smelling, the effluvia of the body smelled, must pass from the object to the organ, otherwise we have no perception. Secondly, there must be some action or impression upon the organ of sense, either by the immediate application of the object, or by the medium that goes between them. Thirdly, the nerves which go from the brain to the organ must receive some impression by means of that which was made upon the organ, and probably, by means of the nerves, some impression must be made upon the brain. Fourthly, the impression made upon the organ, nerves, and brain is followed by a sensation. And last of all, this sensation is followed by the perception of the object. Thus our perception of objects is the result of a train of operations, some of which affect the body only, others affect the mind. We know very little of the nature of some of these operations; we know not at all how they are connected together, or in what way they contribute to the perception which is the result of the whole. But, by the laws of our constitution, we perceive objects in this, and in no other way. There may be other beings who can perceive external objects without rays of light, or vibrations of air, or effluvia of bodies, without impressions on bodily organs, or even without sensations. But we are so framed by the Author of Nature that even when we are surrounded by external objects we may perceive none of them. Our faculty of perceiving an object lies dormant until it is roused and stimulated by a certain corresponding sensation. Nor is this sensation always at hand to perform its office, for it enters into the mind only in consequence of a certain corresponding impression made on the organ of sense by the object. Let us trace this correspondence of impressions, sensations, and perceptions as far as we can, beginning with that which is first in order, the impression made upon the bodily organ. But alas! we know not of what nature these impressions are, far less how they excite sensations in the mind. We know that one body may act upon another by pressure, by percussion, by attraction, by repulsion, and probably in many other ways which we neither know nor have names to express. But in which of these ways objects, when perceived by us, act upon the organs of sense, these organs upon the nerves, and the nerves upon the brain, we know not. Can any man tell me how, in vision, the rays of light act upon the retina, how the retina acts upon the optic nerve, and how the optic nerve acts upon the brain? No man can. When I feel the pain of the gout in my toe, I know that there is some unusual impression made upon that part of my body. But of what kind is it? Are the small vessels distended with some redundant elastic or unelastic fluid? Are the fibers unusually stretched? Are they torn asunder by force, or gnawed and corroded by some acrid humor? I can answer none of these questions. All that I feel is pain, which is not an impression upon the body but upon the mind, and all that I perceive by this sensation is, that some distemper in my toe occasions this pain. But as I know not the natural temper and texture of my toe when it is at ease, I know as little what change or disorder of its parts occasions this uneasy sensation. In like manner, in every other sensation there is without a doubt some impression made upon the organ of sense, but an impression of which we know not the nature. It is too subtle to be discovered by our senses, and we may make 1,000 conjectures without coming near the truth. If we understood the structure of our organs of sense so minutely as to discover what effects are produced upon them by external objects, this knowledge would contribute nothing to our perception of the object, for they perceive as distinctly who know least about the manner of perception, as the greatest adepts. It is necessary that the impression be made upon our organs, but not that it be known. Nature carries on this part of the process of perception without our consciousness or concurrence. But we cannot be unconscious of the next step in this process, the sensation of the mind, which always immediately follows the impression made upon the body. It is essential to a sensation to be felt, and it can be nothing more than we feel it to be. If we can only acquire the habit of attending to our sensations, we may know them perfectly. But how are the sensations of the mind produced by impressions upon the body? Of this we are absolutely ignorant, having no means of knowing how the body acts upon the mind or the mind upon the body. When we consider the nature and attributes of both, they seem to be so different and so unlike that we can find no handle by which the one may lay hold of the other. There is a deep and dark gulf between them which our understanding cannot pass, and the manner of their correspondence and intercourse is absolutely unknown. Experience teaches us that certain impressions upon the body are constantly followed by certain sensations of the mind, and that, on the other hand, certain determinations of the mind are constantly followed by certain motions in the body, but we see not the chain that ties these things together. Who knows but their connection may be arbitrary and owing to the will of our Maker? Perhaps the same sensations might have been connected with other impressions or other bodily organs. Perhaps we might have been so made as to taste with our fingers, to smell with our ears, and to hear by the nose. Perhaps we might have been so made as to have all the sensations and perceptions which we have, without any impression made upon our bodily organs at all. However these things may be, if nature had given us nothing more than impressions made upon the body, and sensations in our minds corresponding to them, we should in that case have been merely sentient, but not perceptient beings. We should never have been able to form a conception of any external object, far less a belief of its existence. Our sensations have no resemblance to external objects, nor can we discover by our reason any necessary connection between the existence of the former and that of the latter. We might perhaps have been made of such a constitution as to have our present perceptions connected with other sensations. We might perhaps have had the perception of external objects without either impressions upon the organs of sense or sensations. Or lastly, the perceptions we have might have been immediately connected with the impressions upon our organs, without any intervention of sensations. This last seems really to be the case in one instance, to wit, in our perception of the visible figure of bodies, as was observed in the 8th section of this chapter. The process of nature in perception by the senses may therefore be conceived as a kind of drama, wherein some things are performed behind the scenes, others are represented to the mind in different scenes, one succeeding another. The impression made by the object upon the organ, either by immediate contact or by some intervening medium, as well as the impression made upon the nerves and the brain, is performed behind the scenes, and the mind sees nothing of it. But every such impression, by the laws of the drama, is followed by a sensation, which is the first scene exhibited to the mind. And this scene is quickly succeeded by another, which is the perception of the object. In this drama nature is the actor, we are the spectators. We know nothing of the machinery by means of which every different impression upon the organ, nerves, and brain exhibits its corresponding sensation, or of the machinery by means of which each sensation exhibits its corresponding perception. We are inspired with the sensation, and we are inspired with the corresponding perception, by means unknown. And because the mind passes immediately from the sensation to that conception and belief of the object which we have in perception, in the same manner as it passes from signs to the things signified by them, we have therefore called our sensations signs of external objects. Finding no word more proper to express the function which nature hath assigned them in perception, and the relation which they bear to their corresponding objects. There is no necessity of a resemblance between the sign and the thing signified, and indeed no sensation can resemble any external object. But there are two things necessary to our knowing things by means of signs. First, that a real connection between the sign and the thing signified be established, either by the course of nature or by the will and appointment of men. When they are connected by the course of nature, it is a natural sign; when by human appointment, it is an artificial sign. Thus, smoke is a natural sign of fire. Certain features are natural signs of anger, but our words, whether expressed by articulate sounds or by writing, are artificial signs of our thoughts and purposes. Another requisite to our knowing things by signs is that the appearance of the sign to the mind be followed by the conception and belief of the thing signified. Without this, the sign is not understood or interpreted, and therefore is no sign to us, however fit in its own nature for that purpose. Now, there are three ways in which the mind passes from the appearance of a natural sign to the conception and belief of the thing signified: by original principles of our constitution, by custom, and by reasoning. Our original perceptions are got in the first of these ways, our acquired perceptions in the second, and all that reason discovers of the course of nature in the third. In the first of these ways, nature, by means of the sensations of touch, informs us of the hardness and softness of bodies, of their extension, figure, and motion, and of that space in which they move and are placed, as hath been already explained in the 5th chapter of this inquiry. And in the second of these ways, she informs us, by means of our eyes, of almost all the same things which originally we could perceive only by touch. In order therefore to understand more particularly how we learn to perceive so many things by the eye, which originally could be perceived only by touch, it will be proper first to point out the signs by which those things are exhibited to the eye, and their connection with the things signified by them; and secondly, to consider how the experience of this connection produces that habit by which the mind, without any reasoning or reflection, passes from the sign to the conception and belief of the thing signified. Of all the acquired perceptions which we have by sight, the most remarkable is the perception of the distance of objects from the eye. We shall therefore particularly consider the signs by which this perception is exhibited, and only make some general remarks with regard to the signs which are used in other acquired perceptions. § 22. Of the signs by which we learn to perceive distance from the eye. It was before observed in general that the original perceptions of sight are signs which serve to introduce those that are acquired, but this is not to be understood as if no other signs were employed for that purpose. There are several motions of the eyes, which, in order to distinct vision, must be varied, according as the object is more or less distant, and such motions being by habit connected with the corresponding distances of the object, become signs of those distances. These motions were at first voluntary and unconfined, but as the intention of nature was, to produce perfect and distinct vision by their means, we soon learn by experience to regulate them according to that intention only, without the least reflection. A ship requires a different trim for every variation of the direction and strength of the wind; and if we may be allowed to borrow that word, the eyes require a different trim for every degree of light, and for every variation of the distance of the object, while it is within certain limits. The eyes are trimmed for a particular object, by contracting certain muscles and relaxing others, as the ship is trimmed for a particular wind, by drawing certain ropes and slackening others. The sailor learns the trim of his ship, as we learn the trim of our eyes, by experience. A ship, although the noblest machine that human art can boast, is far inferior to the eye in this respect, that it requires art and ingenuity to navigate her, and a sailor must know what ropes he must pull and what he must slacken, to fit her to a particular wind. But with such superior wisdom is the fabric of the eye, and the principles of its motion contrived, that it requires no art nor ingenuity to see by it. Even that part of vision which is got by experience is attained by idiots. We need not know what muscles we are to contract, and what we are to relax, in order to fit the eye to a particular distance of the object. But although we are not conscious of the motions we perform, in order to fit the eyes to the distance of the object, we are conscious of the effort employed in producing these motions, and probably have some sensation which accompanies them, to which we give as little attention as to other sensations. And thus an effort consciously exerted, or a sensation consequent upon that effort, comes to be conjoined with the distance of the object which gave occasion to it, and by this conjunction becomes a sign of that distance. Some instances of this will appear in considering the means or signs by which we learn to see the distance of objects from the eye. In the enumeration of these we agree with Dr. Porterfield, notwithstanding that distance from the eye, in his opinion, is perceived originally, but in our opinion, by experience only. In general, when a near object affects the eye in one manner, and the same object, placed at a greater distance, affects it in a different manner, these various affectations of the eye become signs of the corresponding distances. The means of perceiving distance by the eye will therefore be explained by shewing in what various ways objects affect the eye differently, according to their proximity or distance. 1. It is well known that to see objects distinctly at various distances the form of the eye must undergo some change. And nature hath given us the power of adapting it to near objects, by the contraction of certain muscles, and to distant objects, by the contraction of other muscles. As to the manner in which this is done, and the muscular parts employed, anatomists do not altogether agree. The ingenious Dr. Jurin, in his excellent essay on distinct and indistinct vision, seems to have given the most probable account of this matter, and to him I refer the reader. But whatever be the manner in which this change of the form of the eye is effected, it is certain that young people have commonly the power of adapting their eyes to all distances of the object, from 6 to 7 inches to 15 or 16 feet, so as to have perfect and distinct vision at any distance within these limits. From this it follows that the effect we consciously employ to adapt the eye to any particular distance of objects within these limits will be connected and associated with that distance, and will become a sign of it. When the object is removed beyond the farthest limit of distinct vision, it will be seen indistinctly, but more or less so, according as its distance is greater or less, so that the degrees of indistinctness of the object may become the signs of distances considerably beyond the farthest limit of distinct vision. If we had no other means but this, of perceiving distance of visible objects, the most distant would not appear to be above 20 or 30 feet from the eye, and the tops of houses and trees would seem to touch the clouds; for in that case, the signs of all greater distances being the same, they have the same signification, and give the same perception of distance. But it is of more importance to observe, that because the nearest limit of distinct vision in the time of youth, when we learn to perceive distance by the eye, is about 6 or 7 inches, no object seen distinctly ever appears to be nearer than 6 or 7 inches from the eye. We can by art make a small object appear distinct, when it is in reality not above half an inch from the eye, either by using a single microscope, or by looking through a small pinhole in a card. When by either of these means an object is made to appear distinct, however small its distance is in reality, it seems to be removed at least to the distance of 6 or 7 inches, that is, within the limits of distinct vision. This observation is the more important because it affords the only reason we can give why an object is magnified either by a single microscope or by being seen through a pinhole, and the only mean by which we can ascertain the degree in which the object will be magnified by either. Thus, if the object is really half an inch distant from the eye and appears to be 7 inches distant, its diameter will seem to be enlarged in the same proportion as its distance, that is, 14 times. 2. In order to direct both eyes to an object, the optic axes must have a greater or less inclination, according as the object is nearer or more distant. And although we are not conscious of this inclination, yet we are conscious of the effort employed in it. By this mean we perceive small distances more accurately than we could do by the conformation of the eye only. And therefore we find that those who have lost the sight of one eye are apt, even within arm's length, to make mistakes in the distance of objects, which are easily avoided by those who see with both eyes. Such mistakes are often discovered in snuffing a candle, in threading a needle, or in filling a teacup. When a picture is seen with both eyes and at no great distance, the representation appears not so natural as when it is seen only with one. The intention of painting being to deceive the eye, and to make things appear at different distances which in reality are upon the same piece of canvas, this deception is not so easily put upon both eyes as upon one, because we perceive the distance of visible objects more exactly and determinately with two eyes than with one. If the shading and relief be executed in the best manner, the picture may have almost the same appearance to one eye as objects themselves would have, but it cannot have the same appearance to both. This is not the fault of the artist, but an unavoidable imperfection in the art. And it is owing to what we have just now observed, that the perception we have of the distance of objects by one eye is more uncertain, and more liable to deception than that which we have by both. The great impediment, and I think the only invincible impediment, to the agreeable deception of the eye which the painter aims at, is a perception which we have of the distance of visible objects from the eye, partly by means of the conformation of the eye, but chiefly by means of the inclination of the optic axes. If this perception could be removed, I see no reason why a picture might not be made so perfect as to deceive the eye in reality, and to be mistaken for the original object. Therefore, in order to judge of the merit of a picture, we ought, as much as possible, to exclude these two means of perceiving the distance of the several parts of it. In order to remove this perception of distance, the connoisseurs in painting use a method which is very proper. They look at the picture with one eye, through a tube which excludes the view of all other objects. By this method, the principal mean whereby we perceive the distance of the object, to wit, the inclination of the optic axes, is entirely excluded. I would humbly propose, as an improvement of this method of viewing pictures, that the aperture of the tube next to the eye should be very small. If it is as small as a pinhole, so much the better, providing there be light enough to see the picture clearly. The reason of this proposal is that, when we look at an object through a small aperture, it will be seen distinctly, whether the conformation of the eye be adapted to its distance or not, and we have no means left to judge of the distance, but the light and colouring, which are in the painter's power. If, therefore, the artist performs his part properly, the picture will by this method affect the eye in the same manner that the object represented would do, which is the perfection of this art. Although the second mean of perceiving the distance of visible objects be more determinate and exact than the first, yet it hath its limits beyond which it can be of no use. For when the optic axes directed to an object are so nearly parallel, that in directing them to an object yet more distant, we are not conscious of any new effort, nor have any different sensation, there our perception of distance stops, and as all more distant objects affect the eye in the same manner, we perceive them to be at the same distance. This is the reason why the sun, moon, planets, and fixed stars, when seen not near the horizon, appear to be all at the same distance, as if they touched the concave surface of a great sphere. The surface of this celestial sphere is at that distance beyond which all objects affect the eye in the same manner. Why this celestial vault appears more distant towards the horizon than towards the zenith will afterwards appear. 3. The colours of objects, according as they are more distant, become more faint and languid, and are tinged more with the azure of the intervening atmosphere. To this we may add, that their minute parts become more indistinct, and their outline less accurately defined. It is by these means chiefly that the painters can represent objects at very different distances upon the same canvas. And the diminution of the magnitude of an object would not have the effect of making it appear to be at a great distance without this degradation of color, and indistinctness of the outline, and of the minute parts. If a painter should make a human figure 10 times less than other human figures that are in the same piece, having the colors as bright and the outline and minute parts as accurately defined, it would not have the appearance of a man at a great distance, but of a pygmy or Lilliputian. When an object hath a known variety of colors, its distance is more clearly indicated by the gradual dilution of the colors into one another, than when it is of one uniform color. In the steeple which stands before me at a small distance, the joinings of the stones are clearly perceptible, the gray color of the stone and the white cement are distinctly limited. When I see it at a greater distance, the joinings of the stones are less distinct, and the colors of the stone and of the cement begin to dilute into one another. At a distance still greater, the joinings disappear altogether, and the variety of color vanishes. In an apple tree which stands at the distance of about 12 feet, covered with flowers, I can perceive the figure and the color of the leaves and petals, pieces of branches, some larger, others smaller, peeping through the interval of the leaves, some of them enlightened by the sun's rays, others shaded, and some openings of the sky are perceived through the whole. When I gradually remove from this tree, the appearance, even as to the color, changes every minute. First the smaller parts, then the larger, are gradually confounded and mixed. The colors of the leaves, petals, branches, and sky are gradually diluted into each other, and the color of the whole becomes more and more uniform. This change of appearance, corresponding to the several distances, marks the distance more exactly than if the whole object had been of one color. Dr. Smith, in his Optics, gives us a very curious observation made by Bishop Berkeley in his travels through Italy and Sicily. He observed that in those countries cities and palaces seen at a great distance appeared nearer to him by several miles than they really were, and he very judiciously imputed it to this cause, that the purity of the Italian and Sicilian air gave to very distant objects that degree of brightness and distinctness which, in the grosser air of his own country, was to be seen only in those that are near. The purity of the Italian air has been assigned as the reason why the Italian painters commonly give a more lively color to the sky than the Flemish. Ought they not, for the same reason, to give less degradation of the colors, and less indistinctness of the minute parts in the representation of very distant objects? It is very certain that as, in air uncommonly pure, we are apt to think visible objects nearer, and less than they really are, so, in air uncommonly foggy, we are apt to think them more distant, and larger than the truth. Walking by the seaside in a thick fog, I see an object which seems to me to be a man on horseback, and at the distance of about half a mile. My companion, who has better eyes, or is more accustomed to see such objects in such circumstances, assures me that it is a seagull, and not a man on horseback. Upon a second view I immediately assent to his opinion, and now it appears to me to be a seagull, and at a distance of only 70 or 80 yards. The mistake made on this occasion and the correction of it are both so sudden that we are at a loss whether to call them by the name of judgment or by that of simple perception. It is not worth while to dispute about names, but it is evident that my belief, both first and last, was produced rather by signs than by arguments, and that the mind proceeded to the conclusion in both cases by habit, and not by ratiocination. And the process of the mind seems to have been this. First, not knowing or not minding the effect of a foggy air on the visible appearance of objects, the object seems to me to have that degradation of color and that indistinctness of the outline which objects have at the distance of half a mile. Therefore, from the visible appearance as a sign, I immediately proceed to the belief that the object is half a mile distant. Then this distance, together with the visible magnitude, signify to me the real magnitude, which, supposing the distance to be half a mile, must be equal to that of a man on horseback. And the figure, considering the indistinctness of the outline, agrees with that of a man on horseback. Thus the deception is brought about. But when I am assured that it is a seagull, the real magnitude of a seagull, together with the visible magnitude presented to the eye, immediately suggests the distance, which in this case cannot be above 70 or 80 yards. The indistinctness of the figure likewise suggests the fogginess of the air as its cause, and now the whole chain of signs and things signified seems stronger and better connected than it was before. The half mile vanishes to 80 yards, the man on horseback dwindles to a seagull. I get a new perception, and wonder how I got the former, or what has become of it, for it is now so entirely gone that I cannot recover it. It ought to be observed that in order to produce such deceptions from the clearness or fogginess of the air, it must be uncommonly clear or uncommonly foggy. For we learn from experience to make allowance for that variety of constitutions of the air which we have been accustomed to observe, and of which we are aware. Bishop Berkeley therefore committed a mistake when he attributed the large appearance of the horizontal moon to the faintness of her light, occasioned by its passing through a larger tract of atmosphere. For we are so much accustomed to see the moon in all degrees of faintness and brightness, from the greatest to the least, that we learn to make allowance for it, and do not imagine her magnitude increased by the faintness of her appearance. Besides, it is certain that the horizontal moon, seen through a tube which cuts off the view of the adjacent ground, and of all terrestrial objects, loses all that unusual appearance of magnitude. 4. We frequently perceive the distance of objects, by means of intervening or contiguous objects, whose distance or magnitude is otherwise known. When I perceive certain fields or tracts of ground to lie between me and an object, it is evident that these may become signs of its distance. And although we have no particular information of the dimensions of such fields or tracts, yet their similitude to others which we know suggests their dimensions. We are so much accustomed to measure with our eye the ground which we travel, and to compare the judgments of distances formed by sight with our experience or information, that we learn by degrees in this way to form a more accurate judgment of the distance of terrestrial objects than we could do by any of the means before mentioned. An object placed upon the top of a high building appears much less than when placed upon the ground at the same distance. When it stands upon the ground, the intervening tract of ground serves as a sign of its distance, and the distance, together with the visible magnitude, serves as a sign of its real magnitude. But when the object is placed on high, this sign of its distance is taken away. The remaining signs lead us to place it at a less distance, and this less distance, together with the visible magnitude, becomes a sign of a real less magnitude. The first two means we have mentioned would never of themselves make a visible object appear above 150 or 200 feet distant, because beyond that there is no sensible change either of the conformation of the eyes or of the inclination of their axes. The third mean is but a vague and undeterminate sign, when applied to distances above 200 or 300 feet, unless we know the real color and figure of the object. And the fifth mean, to be afterwards mentioned, can only be applied to objects which are familiar, or whose real magnitude is known. Hence it follows that when unknown objects upon or near the surface of the earth are perceived to be at the distance of some miles, it is always by this fourth mean that we are led to that conclusion. Dr. Smith hath observed very justly that the known distance of the terrestrial objects which terminate our view makes that part of the sky which is towards the horizon appear more distant than that which is toward the zenith. Hence it comes to pass that the apparent figure of the sky is not that of a hemisphere, but rather a less segment of a sphere. And hence likewise it comes to pass that the diameter of the sun or moon, or the distance between two fixed stars, seen contiguous to a hill, or to any distant terrestrial object, appears much greater than when no such object strikes the eye at the same time. These observations have been sufficiently explained and confirmed by Dr. Smith. I beg leave to add, that when the visible horizon is terminated by very distant objects, the celestial vault seems to be enlarged in all its dimensions. When I view it from a confined street or lane, it bears some proportion to the buildings that surround me. But when I view it from a large plain, terminated on all hands by hills which rise one above another, to the distance of 20 miles from the eye, methinks I see a new heaven, whose magnificence declares the greatness of its author, and puts every human edifice at a countenance. For now the lofty spires and the gorgeous palaces shrink into nothing before it, and bear no more proportion to the celestial dome than their makers bear to its Maker. 5. There remains another mean by which we perceive the distance of visible objects, and that is the diminution of their visible or apparent magnitude. By experience I know what figure a man, or any other known object, makes to my eye at the distance of 10 feet. I perceive the gradual and proportional diminution of this visible figure at the distance of 20, 40, 100 feet, and at greater distances, until it vanish altogether. Hence a certain visible magnitude of a known object becomes the sign of a certain determinate distance, and carries along with it the conception and belief of that distance. In this process of the mind, the sign is not a sensation, it is an original perception. We perceive the visible figure and visible magnitude of the object by the original powers of vision. But the visible figure is used only as a sign of the real figure, and the visible magnitude is used only as a sign of either the distance or of the real magnitude of the object, and therefore these original perceptions, like other mere signs, pass through the mind without any attention or reflection. This last mean of perceiving the distance of known objects serves to explain some very remarkable phenomena in optics, which would otherwise appear very mysterious. When we view objects of known dimensions through optical glasses, there is no other mean left of determining their distance, but this fifth. Hence it follows that known objects seen through glasses must seem to be brought nearer, in proportion to the magnifying power of the glass, or to be removed to a greater distance, in proportion to the diminishing power of the glass. If a man who had never before seen objects through a telescope were told that the telescope which he is about to use magnifies the diameter of the object 10 times, when he looks through this telescope at a man 6 feet high, what would he expect to see? Surely he would very naturally expect to see a giant 60 feet high. But he sees no such thing. The man appears no more than 6 feet high, and consequently no bigger than he really is, but he appears 10 times nearer than he is. The telescope indeed magnifies the image of this man upon the retina 10 times in diameter, and must therefore magnify his visible figure in the same proportion. And as we have been accustomed to see him of this visible magnitude, when he was 10 times nearer than he is presently, and in no other case, this visible magnitude therefore suggests the conception and belief of that distance of the object with which it hath been always connected. We have been accustomed to conceive this amplification of the visible figure of a known object only as the effect or sign of its being brought nearer, and we have annexed a certain determinate distance to every degree of visible magnitude of the object, and therefore any particular degree of visible magnitude, whether seen by the naked eye or by glasses, brings along with it the conception and belief of the distance which corresponds to it. This is the reason why a telescope seems not to magnify known objects, but to bring them nearer to the eye. When we look through a pinhole or a single microscope at an object which is half an inch from the eye, the picture of the object upon the retina is not enlarged, but only rendered distinct. Neither is the visible figure enlarged, yet the object appears to the eye 12 or 14 times more distant, and as many times larger in diameter than it really is. Such a telescope we have mentioned amplifies the image on the retina, and the visible figure of the object 10 times in diameter, and yet makes it seem no bigger, but only 10 times nearer. These appearances had been long observed by writers on optics. They tortured their invention to find the causes of them from optical principles, but in vain. They must be resolved into habits of perception, which are acquired by custom, but are apt to be mistaken for original perceptions. The Bishop of Cloyne first furnished the world with a proper key for opening up these mysterious appearances, but he made considerable mistakes in the application of it. Dr. Smith, in his elaborate and judicious treatise of optics, hath applied it to the apparent distance of objects seen with glasses, and to the apparent figure of the heavens, with such happy success that there can be no more doubt about the causes of these phenomena. Section 23. Of the signs used in other acquired perceptions. The distance of objects from the eye is the most important lesson in vision. Many others are easily learned in consequence of it. The distance of the object, joined with its visible magnitude, is a sign of its real magnitude, and the distance of the several parts of an object, joined with its visible figure, becomes a sign of its real figure. Thus, when I look at a globe which stands before me, by the original powers of sight I perceive only something of a circular form, variously coloured. The visible figure hath no distance from the eye, no convexity, nor hath it three dimensions. Even its length and breadth are incapable of being measured by inches, feet, or other linear measures. But when I have learned to perceive the distance of every part of this object from the eye, this perception gives it convexity and a spherical figure, and adds a third dimension to that which had but two before. The distance of the whole object makes me likewise perceive the real magnitude, for being accustomed to observe how an inch or a foot of length affects the eye at that distance, I plainly perceive by my eye the linear dimensions of the globe, and can affirm with certainty that its diameter is about 1 foot and 3 inches. It was shewn in the 7th section of this chapter that the visible figure of a body may, by mathematical reasoning, be inferred from its real figure, distance, and position with regard to the eye. In like manner we may, by mathematical reasoning, from the visible figure, together with the distance of the several parts of it from the eye, infer the real figure and position. But this last inference is not commonly made by mathematical reasoning, nor indeed by reasoning of any kind, but by custom. The original appearance which the color of an object makes to the eye is a sensation for which we have no name, because it is used merely as a sign, and is never made an object of attention in common life. But this appearance, according to the different circumstances, signifies various things. If a piece of cloth of one uniform color is laid so that part of it is in the sun and part in the shade, the appearance of color in these different parts is very different, yet we perceive the color to be the same. We interpret the variety of appearance as a sign of light and shade, and not as a sign of real difference in color. But if the eye could be so far deceived as not to perceive the difference of light in the two parts of the cloth, we should in that case interpret the variety of appearance to signify a variety of color in the parts of the cloth. Again, if we suppose a piece of cloth placed as before, but having the shaded part so much brighter in the color that it gives the same appearance to the eye as the more enlightened part, the sameness of appearance will here be interpreted to signify a variety of color, because we shall make allowance for the effect of light and shade. When the real color of an object is known, the appearance of it indicates, in some circumstances, the degree of light or shade; in others, the color of the circumambient bodies, whose rays are reflected by it; in other circumstances it indicates the distance or proximity of the object, as was observed in the last section; and by means of these many other things are suggested to the mind. Thus an unusual appearance in the color of familiar objects may be diagnostic of a disease in the spectator. The appearance of things in my room may indicate sunshine or cloudy weather, the earth covered with snow, or blackened with rain. It hath been observed that the color of the sky in a piece of painting may indicate the country of the painter, because the Italian sky is really of a different color from the Flemish. It was already observed that the original and acquired perceptions which we have by our senses are the language of nature to men, which in many respects has great affinity to human languages. The instances which we have given of acquired perceptions suggest this affinity, that as in human languages ambiguities are often found, so this language of nature in our acquired perception is not exempted from them. We have seen, in vision particularly, that the same appearance to the eye may, in different circumstances, indicate different things. Therefore, when the circumstances are unknown upon which the interpretation of the signs depends, their meaning must be ambiguous; and when the circumstances are mistaken, the meaning of the signs must also be mistaken. This is the case in all phenomena which we call fallacies of the senses, and particularly in those which are called fallacies in vision. The appearance of things to the eye always corresponds to the fixed laws of nature; therefore, if we speak properly, there is no fallacy in the senses. Nature always speaketh the same language, and useth the same signs in the same circumstances. But we sometimes mistake the meanings of the signs, either through ignorance of the laws of nature or through ignorance of the circumstances which attend the signs. To a man unacquainted with the principles of optics, almost every experiment that is made with the prism, with the magic lanthorn, with the telescope, with the microscope, seems to produce some fallacy in vision. Even the appearance of a common mirror, to one altogether unacquainted with the effects of it, would seem most remarkably fallacious. For, how can a man be more imposed upon than in seeing that before him which is really behind him? How can he be more imposed upon than in being made to see himself several yards removed from himself? Yet children, even before they can speak their mother tongue, learn not to be deceived by these appearances. These, as well as the other surprising appearances produced by optical glasses, are a part of the visual language, and to those who understand the laws of nature concerning light and colors, are in no wise fallacious, but have a distinct and true meaning. Chapter 7.